Hello interwebs, welcome to Let's Fix Computers. I have a Dell Latitude E7450 here, which does not turn on. When you plug in the charger, the light goes out. So this is a classic sign that there's a short circuit in the laptop, and to reset the charger I need to unplug the charger and plug it back in again, and now my charger has come back on. So we have a short circuit somewhere in the laptop. When the charger light is going out like this, it's usually somewhere fairly close to the DC jack. So it's the end of the day. I'm hungry for a takeaway. We're going to speed run. So let's go. I'm going to start out by just popping out the battery, and we're going to take the covers off and get to that DC jack. Oh, Latitudes, I love you, but you are a three-piece design, which means you're a pain in the ass to take apart. However, while I'm here, we have got access to the back of the DC jack here. So I'm going to have a quick look with the multimeter and just check if the DC jack itself is shorted, because that will immediately give me a lot of information. And no, the DC jack is not shorted. That's 45 kilo ohms, which is lots. We're looking for at least sort of 20 kilo ohms or higher. I have seen some HP laptops be as low as like 13 kilo ohms, but still we're talking the tens of thousands of ohms, which is absolutely not a short circuit. So what this tells me is it's not going to be the TVS diode or anything like that. This is going to be a short circuit deeper in the laptop. So if we're lucky, it's a shorted capacitor. If we're unlucky, it could be a bigger problem deeper in the laptop, like a bad MOSFET on the CPU or something like that. But I'm banking on it being a capacitor at this point. The downside is that means it's going to be a lot harder to find. The good news for you guys is that means we have to do all the fun stuff, like power injection and things like that. So let's carry on tearing this thing down. Oh, balls, that one's spinning. Keyboard doesn't want to go. Alright, let's see if the bottom cover will come off. I don't think I've actually done a proper strip down on one of these Latitudes before. There's loads of variations of them out there though, so they all come apart slightly differently. It very much feels like the keyboard wants to come off. It's one of those cheeky ones where the keyboard frame needs to come out first. Usually if the keyboard frame is coming off, you're doing it wrong, but in this instance it actually exposes the keyboard screws, as well as all of your keyboard grot. I've been caught out by this before, I'm sure of it. I'll unplug these boys on the bottom, and then the keyboard that seems to be putting up such a fight will just suddenly magically be free. There we go. I have memories of getting immensely frustrated with one of those in the past and damaging it before finally getting the damn thing out. Now we've got the last couple of screws we need for the body. It's easy when you know how, but the problem with this job is that a lot of the time, if you've just never seen a particular model before, it's always your first time taking it apart. There we go. It's unfortunate that we had one spinner there. That happens though. If it's spinning, it's already broken. Right, we're going all the way in. Motherboard out. So I'm going to disconnect any wires I can see on both sides. RTC battery out. The uncommon but not unseen WAN card, or wireless WAN. So this is a cellular network card, so you can stick a SIM card in this laptop and connect to the mobile phone networks. I don't know if anyone still uses these in the wild, because hotspots are just so much easier these days. These things were always a faff to use. I've seen them set up before, and I've had the displeasure of having to set them up before, and every time, like, for a while, every now and then someone would come in and ask me to configure one of these, and I'd be like, nope, absolutely not. This is not a service I provide. Nice. 480 gig SSD. That's mSATA, so it's not NVMe. Right, just connecting the last few cables up here, and then we'll have this board out. Do I need to take the display off? We might be reaching the point where I may as well, because there's so little left. I criticise Dell ThinkPads for being overrated, because everyone's just like, so repairable, so serviceable. I was like, man, they're really difficult to take apart. And I'm a Latitude fanboy, and this is also really difficult to take apart. But I like these because the main bits you want to get to are easy to service. However, actual repair, different picture entirely. And yeah, I'm under no illusion that this is any better than a ThinkPad to disassemble. I mentioned earlier on that it's this is what I would refer to as a three-piece design, where you've got like the bottom cover of the laptop, then the actual chassis, and then a top cover as well. So you end up with this three-piece sandwich. And to get the motherboard out, you've got to do a lot of stripping. Right, and board coming out. Let's have a look. Let's have a feel. Is it going? It's going. It's going. There we go. Right. Put that there for a sec. And I need the DC jack as well. At least it's a heckin' cast metal chassis. Those hinges ain't gonna break. Whew. Alright. Where the hell are the VRMs on this thing? I think they're hiding under the heatsink. Okay. Let's pop the heatsink off, because we got to inspect those. We need to see if we're shorted through a VRM. Okay, a bit deeper we go. So the next thing I need to do is I need to find the short circuit on the motherboard, or, you know, find the shorted rail, which is almost certainly going to be the main power rail because the charger cuts out. So we've got to confirm that, and we need to confirm that it's not shorted through the CPU. Because if it's shorted through the CPU, we may as well give up now. Whereas if it's not shorted through the CPU, then we can continue. So let's wiggle this guy off. Nope. Still no VRMs. Looks like we've got a discrete GPU as well, which is quite surprising. Okay, I cannot figure out how this CPU is being powered at all. Yeah, no idea. If we looked at a schematic or something like that, we could easily figure this out, but I can't. There's none of the usual obvious things where you'd be like, oh, those are clearly VRMs for this one. So not actually sure. So I'm going to go back to the DC jack here, and we're going to start over here. because we've got some giveaways here. So let's start tracing this out. So let me grab a pair of tweezers to point with. All right, these will do. So our power comes in. Where is our DC jack? I shall plug this in because then we can see what is our ground and what is our live. There we go. So we've got two blacks coming in up here. So the top two are black, the next two are red, and the bottom one is our sense pin, or the one wire pin. So we can see that the two red pins, the two black pins, they're going up to this jumper here. The red ones don't connect to anything. They're going through the board. So if we flip the board over, we can see that they are coming through to here. And then they go through an inductor and then straight into a MOSFET. So this is our inrush section. So we go through this inductor because the inductor will resist a sudden change in current. So when you plug in the charger and just suddenly the laptop just goes and starts trying to just immediately soak up current from the charger, this will just smooth that out and just go slowly, slowly, slowly. So we go through that inductor and then we hit the MOSFET. And this is our inrush limiter, which is essentially just a digital switch that allows the EC, the embedded controller, it allows it to switch off the charger if it sees fit. And that is essentially what is going on here. So we go through there and then we hit some more vias. We're going back through the board again. So let's flip the board. And we're coming up here and going straight into another MOSFET, which is the other part of our inrush limiter. And the other side of that, I can't see where that's going, so let's flip the board again. Right, and the other side of that is there, which doesn't seem to go anywhere. So after this, we're going into inner layers in the motherboard. So this one's a tough one to track because we've just plunged into internal layers that are midway in the board. So, however, once we've gone through this guy here, we become the main power rail. So if we start measuring there, we should start seeing information. Let's get the multimeter out. Blurry multimeter cam, go. So we're into resistance mode, and I'm going to stick my black probe on any ground pin. So let's just go for this screw hole up here. It's got some nice divots on. And we're going to check the outputs here. There we go, and we're down to 0.7 ohms, and that's basically the resistance in my probe wires. If I go over to here and actually just touch the probes together, we're only down to 0.6 there. I really need, very frustratingly, this multimeter doesn't have a REL button, an REL button, which basically zeroes it out. It's like zeroing a scale before you use your scales. So I've actually got like 0.6 ohms of resistance just in my wires here. So when we put that probe over there and we see, where was it? And we see 0.76, we're actually closer to like 0.1 ohms or something like that. And the rest of it is all resistance in the probes. So we are in essentially a dead short. The important thing is that we're easily under 1 ohm. If we were shorted through the CPU, we'd probably be seeing about 2.5, 3.5 ohms. 3.5 ohms is a classic sign that you're probably shorted through the CPU. And that means you're going to have a bad time. If you see like 0.9 ohms, that could be a GPU if one is present, because GPUs are super low resistance. However, I'm confident that we're way below that. We are well down into the no, you are in a dead short territory. So at this point, I'm very confident that we can go directly to power injection now and just locate a bad capacitor somewhere. But before we do that, I'm going to do a visual inspection of the board just in case I can spot anything. My track record for this is not in my favor, but I will have a go regardless. So let's start looking around the board. We know it's not directly, we know that it comes after this guy, because if it came before the, if it was before this guy, we would be seeing the short circuit over on the DC jack. And you know what, we can just confirm that. I will just quickly double check that. as you can see, we're back up to that 45 kilo ohms of the DC jack. So it's definitely after this. So it's nothing to do with the DC jack or the input side. So it's definitely on the main power rail of the laptop. Right, I shall now become outrageously fancy and professional and use a microscope to inspect. Massive thanks to Muerto from the Discord for sending me his old microscope. This is an Andon Star, which is one of these digital jobbies with the LCD screen. So this isn't one of the super fancy binocular ones or even trinocular ones where you have two eyepieces and a camera looking down. So I don't get any depth perception under this microscope, but it does allow me to get an exceptionally better and close-up picture of the board for inspection. So switching over to this, as you can see, we have a very close and clear look. The Brio, bless its cotton socks, can be a very good substitute, but it's nothing compared to the real thing. So there is our MOSFET that we were just measuring from. So we're now going to start looking over capacitors and main areas of the board to see if we can see anything suspicious. I'll be surprised if we find anything, if we're honest. It's very rarely visible in my experience. And whenever we find a capacitor, you know, whenever we find it with power injection, there's always someone that's just like, oh, I spotted it. I could see that a mile away. And I'm like, yeah, sure, mate. There was nothing visible. It's kind of like here, like, look at that. There's a spot there. Is that it? Is that a bad cap? I don't think so. But if we see something that's actually got a hole in it, then, you know, that'll be good. But lots of power stuff over here. I'm expecting it to be a capacitor because it always is. But it could be other things. Nothing. Let's start wandering over here. This is memory over here. And we've got the battery charger. Nothing. Okay, I'm going to flip the board over. Don't think we've got a lot of power down here, so I don't think we're going to spot anything. If anything, I'm actually too zoomed in, and this might be easier with the... What about you? What's that? Is that anything? Who knows? This might actually be easier with the Brio, just because I can pull out further. That's the only problem with a microscope. Once you're under a microscope, you're committed to being very zoomed in. Well, I can't see anything. No. There's a lot of things that have a tiny mark on, like that capacitor's discolored. Is that a failed capacitor? If it had like an actual crack through it, then we could be like, yeah, that's it. Like, there we go, that guy looks discolored as well. Could that have burnt out? There's lots of things where it's very easy to point to that and go, that doesn't look normal. But the chances are it could be absolutely fine. Which is why I'm very skeptical. I always do the visual inspection, but yeah. I'm always skeptical of people who say they spotted it. So let's solder some jumper wires on for power injection. Now, unfortunately today, the thermal camera will not be making an appearance because my mobile phone sucks. I cannot get it to work with my mobile phone. It is not a problem with the camera. It's an issue with my phone. And I don't have a spare lined up, so we're going to have to do this the old-fashioned way. The old touchy-feely method that I used to do before I had the thermal camera, which makes this 10 times harder. But hey, I'm sure we'll get through. So I'm just soldering a couple of jumper wires onto this board, make sure they've got a good connection. And now we have a pair of wires with a short circuit between them, which I shall now confirm. Whoop. Black and red. And there's our short circuit. Nice deep 0.4 ohms there. Lovely. So I shall now plug in my bench power supply. So I've got my power supply set to 1 volt, and we're going to start off at 3 amps. We're going to have to go fairly high today because we're going to have to feel it out with the old fingertips. There are other methods of doing this, you know, the rosin flux method. Then there's also the alcohol method, and there's freeze spray as well. I'm not actually set up for any of those things because these days I'm set up for a thermal camera, which doesn't heckin' work. I'm furious. Let's move on. Right, let's turn on the power. All right. So as you can see, we've sunk down to 0.64 volts at a full 3 amps. So that's a good sign. We're sinking lots of power into this short circuit, which means something is heating up. So I'm going to start looking around the board. I'm going to get my tippy fingers out and just start looking for warm spots. Now, if I had my thermal camera, this would be a breeze. We'd be done in seconds. We'd point that thing at the board and I'd say, there it is. But now we have to do it this way. So I'm going to fast forward through this bit. I think it's over here. This area definitely feels above ambient. There's a lot of power over here though, so it's a heavy section of the board. I'm going to give it more beans. 4 amps go. Neither of these are getting hot enough to burn my finger, and they should be. But there's definitely heat here. Don't make me put more power in. I don't like going over 4 amps. Let's go super close in on this area and try some alcohol. Yeah. One on the left went first, I think. They're both drying out fairly quick, but the one on the left is definitely the first to go. I think it's that guy. I'm confident enough that I'm going to take it off the board and find out. This would be so easy. I've been spoiled by having the thermal camera for a short amount of time. I will be getting it sorted. As I mentioned, it's an issue with my phone, and I've been threatening to buy a new phone for a while now. Gotta be done. So, firstly, has our short disappeared? It has just. What's that? That's 886 ohms. I feel like we should be up in the kilo ohm range here. Although it's still very hot there. However, we're not in a dead short. What about the cap? The cap is dead short. So we definitely had the right capacitor. So now the question is, what is the cap that we've just removed? I'm going to see if I've got a schematic for this. This is an LA8963P. Do I have a schematic for you? No, I can't find it. So in that case, I'm going to take the other chip off the board, and we're just going to check what that one is. So it's not a sure thing, but there's a very high chance that this one on the right will be the same value. So I'll take this off and measure it. So we'll take the multimeter into capacitance mode, nanofarads, and let's see what we get. My component tester makes this easier, but I can't be bothered to go and find it. 20 mic, really? Yeah, 20 microfarads. Sure, okay. I would normally expect it to be in multiples of 100, but sure. I was expecting a 10 microfarad or something like that. However, apparently it's 20, so I shall find a 20 microfarad capacitor. So again, there's not a sure thing that that the other one is also 20 microfarad, but in my experience, it usually is. Even if it's supposed to be 10 microfarads, we'll find that it'll be fine. There's a strong argument that we could get away with not replacing it. However, if you can replace it, do, because unless you can tell me exactly what that capacitor is doing with authority, we can't be certain that it's not critical. So these are 0805 capacitors that we're dealing with here. So I'm going to have a rummage in my 0805 capacitor kit, which is an eBay special. Only the best quality capacitors here. And we are looking for a 206, if my memory serves me. And I don't have one, so in that case I'm going to stack a couple of 106s there. So capacitors work in the same way that batteries do. When they are wired in parallel, you combine the capacitance, and when they are wired in series, you combine the voltage tolerance. So by putting two 10 microfarad capacitors in, we add in the equivalent resistance of a single 20 microfarad capacitor. I'm going to turn my airflow right down now so we don't blow all of this away. I should have put fresh solder on these pads. There we go. And I'll just add some extra solder to the bottom of those just to make sure they're all happy. And yeah, these are all parallel together, so it's completely fine for me to just solder blob both ends. There we go. Like I bought one. Oh, the microscope shows all the smearing from the flux residue. Now I have to clean it properly. And double checking for shorts. No shorts. We're up at high resistance now. It's tumbling down because that's what they do, but... Okay, so I should be able to take a quick pot shot at this now and just plug in the charger. Ugh. So if I plug this guy in now, and the light has not gone out. There we go. So now we'll put the laptop back together, and there is a very good chance that that is going to work. So let's pop off these jumper cables, and I will reassemble the laptop. Right, we have enough all hooked up to actually do a power on test now. Well, we're past that point, but there's a lot of screws in this laptop, and I'm going to find out if I'm wasting my time or not before I put them all in. So I've just plugged in the power cable. It has turned on by itself. So we'll just wait for it. It probably needs to memory train and stuff. Okay, it's turned off again. And now it's come back on. Cool. Okay, I think it's memory training. I'm going to wait for a picture before I carry on. There we go. It lives again. I'd like to see the cooling fan move. Ah, there we go. Good. Yep, that CPU fan has come on now. I always get a bit worried when fans don't spin at all. They should be spinning. So yes, I like laptops where, I like any device where the fan will spin up for a couple of seconds when you turn it on and then switch off again if it's not needed. So you get that initial spool up just to let you know that it works. So, okay, let's power that off. So the laptop did not start up. I think that's because the BIOS has been reset and it's probably trying to boot in legacy mode when it needs UEFI or something like that. We'll fix all of this in a moment. Let's finish reassembling. And one fixed laptop. Just having a good think about it. There's drive activity. There we go, there's the Windows spinner. It looks like it just needed another reboot just to settle down. Good, we're all done here. This thing just needs a physical clean now, and we are all finished. Thank you for tuning in, everyone. This was another dead capacitor, which we found with the touchy-feely method, which we haven't used in a while. I will be back next time with something else, and hopefully I'll have a new phone so I can actually use my thermal camera again. And once again, because I know people will make comments on it, it's not the camera, it is my phone. My phone just hates external devices, and I don't know why. Also, where does the SD card go into this thing? It goes in there. See you next time, folks. Bye.